At the beginning of the pandemic, the London Philharmonic put out a couple of very cool videos with their low brass section playing excerpts from Bruckner's symphonies, and talking about them and explaining their role in them and so on, but only the low brass. So that's a quartet of the three trombones and the tuba, who don't really get to play that much, but when they do, in those very big, very romantic and heroic late 19th century symphonies, well, they basically get all the fun. They have the foundation and the main facade of those awesome tutti. Watching those videos, I got the idea of looking into one of those passages because I know that Bruckner's harmony is fascinating in that it is very far removed, very evolved away from the 18th century harmonic language, but not in the way that Beethoven would kick off, and that would take up most of the 19th century. That's based on ever-increasing complexity and more dissonant harmony, with chords with more and more notes that have more and more possible resolutions, so there's a lot of tonal ambiguity, tonal vagrancy, all of that we've seen in several of our videos before. By the end of the 19th century, what we see actually is a simplification of the language, at least of the vocabulary of that language, the chords themselves. And even so, the harmony is completely new, completely fresh. So I thought it would be very interesting to see how it all works and to try our hand at analyzing one of those passages. In particular, this particularly awesome one from the finale of Bruckner's 8th Symphony. Okay, so we have three phrases that are actually three iterations of the same phrase at different pitch levels. So that's what's called a sequence. And the last phrase, of course, has a tail at the end that is not part of a sequence. And then it also kind of does sound a little different, even in the first part. But that's just because of a change in voicing. Bruckner had to trade the voices and trade the octaves just to keep the music within the register of the trombone. But I did check, and the phrase is still a repetition of the first two phrases. So it is a sequence, and interestingly, it's a sequence by fifth. So between F sharp and B, and then between B and E, there's a fifth. And in fact, since the last chord in each of the phrases is a major triad, there's even a dominant tonic relationship, a 5-1 relationship between the phrases. So it's interesting to see that the circle of fifths is still operating, at least at the level of a phrase. But let's look inside the phrase, because from the way it sounds, I don't think it's going to be as straightforward. The good news is that since they're all the same, we can just look into one of them. So let's look into the first one, the one in F sharp, which starts with an F sharp. All the four members of a quartet have just F sharp. And I checked on the full score to see what the rest of the orchestra was doing. And sure, the violins do have a C sharp, but kind of as a passing ornament. Other than that, everyone is just doing F sharp. This is a thirdless chord, meaning that we don't know if it's major or minor. The context of the symphony puts it in minor, but let's put an asterisk there, because that's a minor that's implied. That's not explicitly a minor triad. And then there's that awesome moment where the F sharp unison unfolds into a full triad of D major. And it just sounds incredible, the unfolding of the unison into a full-blown triad. Really cool. But from the harmonic point of view, well, D major is just 6 in the key of F sharp minor. So this kind of confirms that we were in minor, but also is just absolutely part of a normal progression. 1 going to 6 is nothing new. The next move, however, that is something else, because B flat is not part of either F sharp minor, nor is it part of D major. And in fact, there's no key, there's no single key in which you will find both D major and B flat minor. So this is a progression that you won't find in the canonical circle fifths driven harmonic syntax. Not in Mozart, not before Mozart, even after Mozart. I don't think you'll find this in Chopin or Schumann or Brahms or any composer that's just exploring the circle of fifths. And I think you can tell just from the way it sounds. It has a very special sound. It's a very special connection that's not based on the dissonance resolution paradigm. So it has that almost modal feel, even though it's by no means modal since the two chords are not even in the same scale. But it does have that non-functional feel, and that shows you how far removed this is from the circle of fifths progression that creates functional harmony. So, what are we going to do about this chord? Well, one thing that might help is to realize that B flat is the same as A sharp. So this is a chord of A sharp minor, which still is not part of F sharp minor, but it is in the scale of F sharp major. It's 2 steps up. Oh, look at this. So the previous chord was 2 steps down along the minor scale, and now we have 2 steps up along the major scale. So it's kind of a nice symmetry there. In fact, they're both major thirds, right? So it's like we went away from the F sharp down by major third, and then we're approaching it again from up a major third. So it's kind of a circle of major thirds. And yeah, in fact, it is an exact analogy with the normal circle of fifths progression. So the canonical 1-4-5-1, that is moving away from tonic by a fifth and then returning to tonic by a fifth as well. So it's the same that's happening here, only we're replacing the fourth with the major third. Now it makes it sound really interesting and different, because the major third, you won't find both a major third down and up from a tonic in the same scale. So the symmetry based on a major third will kill the normal diatonic scale. And the thing is that with it, it kind of also kills our hopes of putting any Roman numerals on it. Although there's still a case to be made that that chord of A sharp is actually functional, because that's the chord of 3. And the chord of 3, especially in inversion, we featured that chord in our analysis of Mozart's Fantasia. So when you take a dominant chord and you substitute the 6th for the 5th of a chord, then you get the chord of 3 in inversion. So you can say this B flat minor chord is functioning as 5/6 in the key of F sharp, which is our key anyway. Now there's a couple of wrinkles there. First of all, we do have that chord of 3 in root position right after, right? And when you're talking about root position, then that substitution is awkward because it implies that this substitution happens on the bass, more of a stretch. And then also, this alteration of 5 does create a chord of 3, but only in the major mode. So we still have to posit the instantaneous mode change there and so on. So all these things are adding up to make this kind of explanation more and more awkward and far-fetched. On the other hand, the good news is that with all the featuring of thirds all over the place, there is an analytical approach that might actually help here. So let me show you by setting up the notes of F sharp like this. So the root and the 5th on a line, and then the major third on the top, and we can also put the minor third at the bottom. So we have a rhombus with the F sharp notes, the F sharp triads. The upper triangle is the major triad, the lower triangle is the minor triad. And the thing is that the 2 notes on the left are also part of another major triad that we can complete like this. And on the other side, the right-hand side, we can complete another minor triad. And what do you know? This is the circle of thirds in our piece. This is the progression that we've seen, D major and B flat minor on either side of the F sharp rhombus. So this is a really cool and really promising way of looking at this, which in fact is only part of an infinite plane, an infinite lattice called the Tonnetz, where we can keep on adding notes and triads, and we'll have the full triadic space. And then we can explore this lattice as a lattice and start looking at the way triads, meaning triangles, move into one another. So if we take that basic major triad triangle, there are three basic transformations from it. You can move to the parallel triad, the minor triad, along the horizontal line, or we can move to the relative triad along that diagonal, or you can move to what's called the leading tone transformation, because we're trading the tonic of a triad for the leading tone. So those are the three basic transformations, P, L, and R. You can go in either direction along each of the three sides of a triangle. So with this, we can take our progression and we can identify the move that's happening between the triads. So that major third move that we were talking about, that would be a leading tone transformation. It happens on both ends of this progression. And then the one in the middle, that's not as straightforward. That's actually a compound transformation made up of three moves, which turn out to be L, P, and L. Now that compound transformation, LPL, it actually has a name within this theory. This theory is called neo-Riemannian analysis, and it gives the LPL transformation the name of hexatonic pole for technical reasons. And if you ever look up basics of neo-Riemannian theory, you actually might find it defined as PLP rather than LPL. That's because the two things are actually the same. If we apply PLP instead of LPL, we're going in the other direction, but eventually we'll reach that same triad of B flat minor. But in any case, the cool thing is that the Tonnetz is showing us directly the circle of major thirds that we find in the piece. Just as it would show us the circle of fifths, the original circle of fifths with 1, 4, and 5, which happen to be along the horizontal axis. And in fact, this was the first use and the first approach to the Tonnetz in music theory, developed by Hugo Riemann, beginning of the 20th century. Still a little tied to functional harmony and dominant and subdominant and so on. The theory nowadays, after a revival in the 80s, is less tied to those concepts, and that's where we get the name neo-Riemannian theory. And that's because since the Tonnetz also has a vertical dimension, it not only shows the circle of fifths, but as we've seen, it has the circle of major thirds and also the circle of minor thirds right there built in. It's a very economical way of showing how this phrase that we've been looking at responds to the circle of major thirds the way it does. So, if you remember that third iteration of a sequence has also a tail, a second motive, and then that second motive will be sequenced by itself in what would be the fourth phrase of this whole section. So what we'll do is look at that sequence of the second motive, and that's going to be the second part of this analysis. Separate video, but very much part of the same thing. So I hope you come along, hit subscribe, like this video, comment. I'm very curious to see if people already knew of neo-Riemannian theory, so leave a comment, and I'll see you in the second part of Bruckner's 8, Neo-Riemannian Awesomeness.